Hi guys, today's video is about using a hot water heater as a source of heat for radiant heat floors, hydronic radiant heat floors. Before I share the details of this video, let me preface this by saying I am not a licensed plumber. Never was, probably never will be. I am a DIY guy, do it yourself, and I've watched several videos online, including another gentleman's video where I basically got my idea from. So I hope this helps you. I'm going to mention some brands and some companies throughout this video. This is not a sponsored video in any way. I'm just telling you where I bought these things from, hoping that it might help you in some way. So before I get started with the details of the mechanics, let me show you this space. So the space looks like this. It's basically an apartment. Okay, one bathroom, small kitchen. Anyway, you get the gist of it. And this is that luxury vinyl tile clipped together tongue and groove flooring. Looks good, and hopefully it does well with the radiant heat. And this is the utility room, obviously. So one thing I wanted to show you is the height of the floor. So as you can see, it's a few inches over the top of this floor. The entire apartment at one point in time was the same height as this. It's a concrete slab, 4 or 6 inch, whatever it is. And I used the Uponor Fast Track, I think 1.3, if I recall correctly, panels that you lay down. They have maybe a half-inch foam insulation, styrofoam on the bottom. The top of it is looks like the underside of a soccer cleat, and you can weave the PEX tubing in and out. I can share pictures of that with you if you'd like, but this is the overpour, which is a gypsum overpour. That's what the manufacturer calls for. Gypsum overpour. I suppose you could use concrete and perhaps some other overpours, but I used gypsum overpour. And it was a self-leveling overpour. It turned out beautiful. Everything is perfectly level. I didn't even have to shim the kitchen cabinets. That's how well it worked. So this is the manifold that I installed. And this is one thermostat and 3 loops, not 3 zones, 3 loops. So each loop is about 300 feet, half-inch PEX. So it's about 1,000, well, 900 feet, I suppose, minus whatever the distance is here, of half-inch PEX. That's woven in and out of the floors here. I think the spacing I used was about 8 inches apart, 6 to 8 inches apart. So let me show you what my initial intentions were and why we abandoned that idea. So initially I installed a thermostat early on in this project. I'm sorry, valve zone, or zone valve rather, and I put a valve here to valve this off. So there are 3 zones currently in the house: first floor, third floor, second floor, and this was to be the radiant heat. It's capped off, and this side of it is also capped off, okay, with a valve. So there were a few issues with this. First of all, this is a non-condensing boiler. It's about 80% efficient, I'd say, if that. And I believe the temperature coming out of here, I'd have to read the tag, but let's say it's 180 degrees, right? 160 to 180, something like that. Well, you can't send that water into this manifold and into the floors. Way too hot. So similar to a valve in the shower, where you have the hot coming in and the cold coming in to this mixing valve, this would be the shower head. the part that actually comes out of the shower head. So what this is doing with the adjustment of this knob, you can see I have clockwise is cold and counterclockwise is hot. So you turn this way or this way to make it hotter or colder, and you can adjust the temperature of this. And what goes into the floor is the mixed portion. And if you look on the mixing valve, it does say mixed. So the purpose of that was to step down the temperature here. So to mix, this would have been coming from the boiler in here. This would have been the return. And what you're doing, which tees off, right? Part goes back to the boiler and part goes into the system. This was mixing it and sending the reduced temperature water into the manifold and into the floor. Okay, but the problem is on the return side, when you're coming back into the boiler, you have to step that temperature back up because you could have condensation where you have water that's too cool going into a boiler that's very hot. You get moisture in the boiler, that could cause problems. I also had a professional plumber tell me that you don't want to put the additional strain on this boiler. It's an older boiler. He called out several other issues with this boiler. Basically was trying to sell me on a new boiler, I believe. But at the end of the day, this boiler has always worked fine. I didn't want to compromise it. I didn't want to get involved. It started getting too complicated with stepping the water down, which was simple enough using the mixing valve, but then stepping it back up using some kind of bypass, and maybe a mixing valve going back. I just said, forget it. Let's just leave this alone. This is the heat for the house, and this is the hot water heater that I installed for the house. This is for your showers and your hot water. This is not for the radiant heat system. This, however, is for the radiant heat system. So one of the things that I should note is I used a LoopCAD program to determine the heat loss. I know there's going to be a lot of critics who say, you got to do this, you got to do that, you're supposed to do this, you're supposed to do that. Well, I did those things to determine the heat loss. I also determined that the amount of water in nearly 900 feet of half-inch packs was around 6 or 7 gallons. It wasn't all that much. This is a 30-gallon water heater, which seems to be working just fine. You can get into the weeds with BTUs and blah, 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 and a plumber, I suppose, would do that or would have to do that or be expected to do that. I'm not a plumber. I'm a DIY guy. So this is how I set this up. This is where I placed it, so we have access underneath the crawl space here. And this is separate from anything else, okay? It's its own closed circuit. However, I do have, this is the municipal water, and I do have a pressure reducing valve with a backflow preventer built in. And I also included my own valve here if I ever had to service this. This was used to feed the system. Now, I'm glad I did this because some others are feeding the system with a garden hose in bleeding this, and I can show you how to do that later. In bleeding this system, all I did was, lift this up and fed more water in. This, I think, is set to 15 pounds. This system pressure is about 15 pounds. The return pressure looks like it's about 15 pounds. This is coming out at about 120 or so degrees. So that's what I'm sending into the system. And let me walk through it with you. I should mention that this backflow preventer prevents any of this water, this sort of closed circuit or closed loop water, from flowing back into your potable water. Of course, you never want that. I should also mention that this would typically be hooked up, I believe, on the cold side. In this case, I have it hooked up on the hot side because just the way this was positioned, it was easier to do that, to hook it up to that side. So that's what I did. I put valves wherever I could. If I ever had to service this, I could simply close this valve, and I'd have to cut this and cut this. Now, here I put these braided stainless steels, which makes it very easy to disconnect. The reason I didn't do that here was because of the weight of some of this. I wanted this to be rigid and strong to support this. So that's why I did that. So no big deal. Whenever we have to change this, we'll cut it here. And, you know, I would just sweat in, you know, coupling like that. So this comes out, this is the hot side. This is the source, right, if you will. This is the cold side, just a standard water heater. This happens to be natural gas. So this comes up. Again, I have a valve here. This system, when needed, is fed. If the pressure in this system were to drop below the setting here, then this would open to allow more water in. So I suppose if you had a leak somewhere, this would continue to feed the system, and that leak would just keep going, unless, of course, you close this valve, which is why I have it here for servicing and also if that were to happen, God forbid. Okay, so going up, I have a gauge here. So this system's operating at around 15, a little less, 12 maybe, PSI. And the temperature, I don't have it on right now, but this would normally be around 120, 110, 120 degrees. So anyway, that goes into this air scoop with the air bleed on the top. That's to eliminate any air. I would still recommend bleeding the system through the manifold to get most of the air out, and this over time would remove any other air. If there's any evaporation or anything in the system, I don't understand how that would be, but they say it's possible. And the system were to become low in water and the pressure was low, this would kick on to fill the system back up, as I mentioned before. So you can see the directional arrows. A lot of this stuff, circulator pumps certainly, these things have arrows in terms of how this flows. So this flows through here. Okay, here it is again, and goes to the mixing valve. Now, let me back up. This is has a bladder in it. This pressure is set to 15. So I think this is set to 15 and this is set to 15. I think factory setting was like 50 pounds. So I simply unscrewed this and drained the air out. So this is 15 right now. And I even wrote it on here somewhere. I don't know where I wrote it, but I wrote 15 PSI. Oh, there it is. 15 PSI. All right, so again, going back into the mixing valve. So this hot water is mixing with the cold water in the return. And the mixed, as I mentioned, is going into the circulator pump. Now, circulator pumps, I happen to have this one. I owned it. Some of them have valves, flanges with valves built in. That's great. I didn't have that. So I put a valve here and a valve there. If you ever had to change this, close the valve, unbolt it. No problem. Okay, one circulator pump that's pumping everything through here. There are 3 speeds here, sort of high, medium, and low. I have it set for the middle. There are very technical ways you could, there's some technical things that you could determine as to what exactly that should be set at. I have it set in the middle. It seems to be working fine. Goes here into the hot side. There's a valve here going into the manifold. Also, there's a temperature gauge here. Okay, going into the manifold. This is how you adjust the flow rate, gallons per minute. So you're going to have certain rooms that are a certain number of gallons per minute and other rooms that are different, and you can screw these in and out to adjust the gallons per minute. Okay, I was bleeding the system right now, so this and this happen to be open. Okay, and one of these two are closed at the moment. because what I was doing is bleeding the air from these. These are covers here, and they have like a little Allen key head there, and underneath is you use this little tool, which is very handy to open that valve. I happen to use a bucket, and this is from a washing machine. I'll screw that thing right in there. And they tell you to do one at a time. So open the first loop, bleed the air, close it. Open the second, bleed the air, close it. Open the third, bleed the air, close it, and then you can open them all up once you feel that you've bled the air. So let's talk about the circulator pump. The circulator pump goes to this taco, I believe is how you pronounce it. It's not taco, I know that. SR501, one zone. I happen to have one zone here. Switching relay. I followed the instructions on how to wire this. This is pretty straightforward. However, the main feed is coming from this receptacle, and it goes up, in this case over the door, over here, along with the thermostat wire here, and goes into this first, so that I have an emergency shut-off switch. This is code. This goes into the emergency shut-off switch. This controls the power out of this and into the switch relay. And the switching relay, basically when this is calling for heat, it's sending the message, if you will, through the thermostat wire, to the switching relay, which is switching power to this outgoing wire that goes to the pump, and then the pump pumps it around. Now, there was another gentleman online on YouTube that posted a video. He had a timer. The rationale being that this heats up and at times and is not heating at other times. So he was setting the timers in half-hour increments so that it would kick on and kick off. So, the reason I didn't do that, although I thought it was a good idea, was because then it meant resetting the time and you couldn't use this schedule on the thermostat. So I didn't want to do that. I opted not to do that. However, I did think that was a good idea when you're using a water heater, as I am here. So anyway, it goes into the loop, it comes out on this side and goes back, and this is where the return water, right, returning to the water heater, is mixing with the source water, the supply and return. That's why this is teed off. The return does have to go back, so you have to tee it off. You can't just bring the return into there. You have to tee this off. I'm assuming you know that. Goes here. I have another gauge, so I know what the return temperature and pressure is, and that goes right back in. This is a pressure relief valve that, should this exceed whatever this is set for, I forget what it is, 60 pounds maybe, it would, instead of exploding, it would blow out the bottom. So you do have to have these go all the way down, within a few inches of the ground. I don't know the exact code. This is a vent too, same idea, that just goes down. This I bought from Amazon. It's a Watts pressure reducing valve with a built-in backflow preventer, 1/2 inch. This is threaded, and this was sweat on one side, threaded on the other. And this I bought from, and this is a gallon. The size of this is a gallon. This I bought from Supply House online. This I also bought from Supply House. This I bought from Supply House. These gauges I bought from Supply House. Bought these from Supply House. This is 3/4. by 3/4 by 1/2 inch is what these gauges happen to be. Okay. Valves I bought at Home Depot. This I bought at Home Depot. This is Uponor. This tubing's also Uponor. This I bought from Supply House. This I bought from Supply House. This I bought from Home Depot. This I happen to have, but if I didn't, I probably would have gone through Supply House. And this I bought from Supply House. So all in all, I think I have, I think this was around, don't quote me, but 500 or 600, something like that. This, I'm just going to round off here. This was a few hundred. You know, these you can see in the Home Depot, maybe they're $20-something, maybe $30. You know, I think all said and done, I'm about $1,500 here. Obviously my own sweat equity and labor here. You know, copper piping is expensive now. Maybe always was, but it's really expensive now. So I was able to do this for, let's call it, under a couple $1,000, or around there. I guess that's it. If you guys have any questions, please let me know in the comments. If you are a professional in this field, go easy on me. Again, do your own research to determine what would work best for you. Certainly read the comments here to make sure you understand, and you'll get an opportunity to read other people's suggestions, especially professional suggestions or suggestions from professionals. But that's it, guys. Hope it helps.